I used to intern at GE Capital. I did like an internship here in my undergrad degree, and I used to hate coding, hate coding, hate coding.
Today's special guest is Richmond Alake. Richmond is a computer vision engineer based in London. He has a master's in computer vision, machine learning, and space robotics. Richmond believes in sharing knowledge, and you can find some of his machine learning-based articles on Medium, where he's been a top writer in the artificial intelligence space for the majority of 2020. They're linked below as well. When he isn't working on deep learning or writing articles, Richmond spends his time exploring new technologies and side projects. One of which is Moretion, a smartwatch that can track the proximity between your hand and face. And it sends an alert when your hand is touching your face. The main focus of this application is for maintaining cautiousness around the COVID era. In this interview, we learn how Richmond chose his unique master's degree, how he transitioned into data science from a full stack software developer, and how you can get started with computer vision on your own time.
All right, Richmond, thank you so much for coming in, allowing me to interview you here. I had such a good conversation with you last time when we did our little intro call. And it's funny how we actually met. You wrote an article about why it's important to, I guess, share your own content on the internet. And I read it and I was like, I need to speak with that guy. So,
Yeah.
So I obviously gave a little bit about you in the intro, but I'd love to hear a little bit more from your mouth about how you got interested in the data science and machine learning domain. I know you come from kind of this long storied path that's a little different than a lot of my other guests. So I'll turn it over to you.
Okay. I guess how I got interested in the whole machine learning field is probably a natural progression from like my growth mindset that I developed during my undergraduate degree. So generally just accumulating as much knowledge as I can. So my undergrad degree was in software engineering. Then right after graduating, I worked as a web developer for about a year and a half. And within that year and a half, I worked in about 4 different companies, which is actually quite, doesn't really look good on your resume because people think you're just job hopping. But what I was doing is accumulating as much experience as I can. And as soon as I see there's no more benefit, I'm moving on to the next challenge. That seems scary when I start, but when I finish, it's just natural and just becomes second nature. So right at the end of the whole 2-year stint of web development, I sort of reached a roof, I feel, is in I was a full stack developer. I knew about the front end, the back end, databases, DevOps, a bit of cloud services. And I thought, what was a natural step? And machine learning just obviously was everywhere. There was a hype, it was on the news. So I just went straight into machine learning. And just like probably every machine learning practitioner out there, I watched Andrew Yang's Coursera videos on machine learning and neural networks. And that's how I first got started. And yeah, I got hooked, as in I understood some of the maths and it made sense. And I decided to explore it a bit further. And one thing is I was doing a bit of learning in my own time, but work was actually quite time consuming. Like I had massive roles and responsibilities and I couldn't sort of balance the two, where I was working in the web development during the day, then doing maybe 2 to 1 hour learning in the evening. As in I couldn't balance the two because work was sometimes demanding. I had to like work long hours and stay back. So I decided to commit myself full time to machine learning. So I went straight into taking a master's in machine learning, computer vision, and robotics. But really, my interest in AI, data science, machine learning, it stems from a natural progression of having a growth mindset, right? So I started with web, then now I'm in AI. And in the next 10 years, I don't know what I'll be in, but it will be at least at the edge of technology advancement.
That's awesome. So I think to clarify for anyone watching what a growth mindset is. So there's 2 types of mindsets. One is fixed, where you think that you're only capable of a finite amount of things. You hear people with a fixed mindset will usually be telling you, oh no, I can't do that. Or, this is something I can do, but these are the other things I can't do. A growth mindset means that you believe that you're capable of positive change and you're capable of growth. And the growth mindset, as I'm sure you're familiar with, is very highly correlated with success on the job and also in kind of in general life. So just for a little bit more clarification there. One thing I really wanted to highlight, it was a small thing you said, but I absolutely loved it, was that a lot of the things that you were pursuing were really difficult to start with, but now you look back and it's like, oh, that wasn't that hard after the fact. After you got there, it becomes second nature. And that's 100% happened to me with data science. You look at like building simple models, creating a pipeline, even creating an API or something. Those were all really hard the first time I did it, but each sequential time I did it, they were easier. Even something like a Rubik's Cube that I did, I remember when I first started fooling around with it, I was thinking that I would never be able to do this. And now I can do it in a couple minutes and I just kind of flip it around, right? I mean, it's crazy how impressive, one, the human brain is, to be able to take apart these tasks, but two, like the kind of walls we put around things that we think are difficult, because a lot of these things seem overwhelming, but after we get into them, after we learn them, we look back and they really weren't that hard. And we're just capable of a lot more than we generally think we are. So I'd love to go ahead. Sorry.
It's a true story. And most of my friends most of my friends didn't think I would actually get into development because I used to intern at GE Capital. I did like an internship here in my undergrad degree, and I used to hate coding. I used to avoid all the coding tasks. I used to literally hide. And I used to say, don't give me that task. I don't want to code. I'll do the design or write the technical requirements, but don't make me code. But one day everything just clicked, and here we are.
Yeah, sometimes you just have to do it, and you like realize you like it. In all through college, through my first master's degree, I had never written a line of code. If you'd asked me if I ever would, I would have told you no. And look at me now. So I'd love to drill into your experience with grad school. So, one, what went into making that decision? Two, what did you learn there? And three, is that, do you think that was the right decision? Is that something you would recommend to other people? I can go back through those if you need when the time comes.
Yeah, sure. I'll try to remember. So first, what made me go to grad school? Like I said, I needed to sort of learn what machine learning was about, but more specifically, I needed to sort of dedicate like a year and full time to actually learning all the concepts and ideas between computer vision, machine learning. So the course I took was a master's in computer vision, machine learning, and space robotics. So computer vision was only like 2 modules out of 8 modules that I had. So really what drove me into grad school was just being in a space that allowed me to focus on, I guess, AI as the broader term. And again, but what was the second thing?
Well, so the second thing was what, like what type of stuff did you learn? But I'm also interested in how you found that grad program. I get a lot of questions about, which program should I take? Are these any good? And I can't answer those. I haven't taken the programs. So I think from your perspective, how did you evaluate that program?
Yeah, so firstly, the selection was pretty, again, I would say natural because most of my friends did masters at that university that I went to. But then it was between either going to Imperial College in London or University of Surrey, which is in Guildford. And I had to select between the two, and they both had similar programs. They touched on similar topics, as in maybe a few different modules here and there. But generally, what it came to was between those 2 universities, and just came to the price, as in University of Surrey was much cheaper than Imperial College London. So I went to the cheaper option, and that's how I chose University of Surrey. But they pretty much had the same course content and just touching on the basics. So neural networks, convolutional neural networks. And I guess the space robotics that Surrey had, that space robotics element just made it sound cooler. Like when you told people, yeah, I did space robotics, like wow. But But yeah, that was actually one of my weakest points, but weakest modules. But yeah, that's how I basically selected University of Surrey.
Well, it definitely sounds cooler to employers as well. I think a lot of people get really wrapped up in the school name or something like that, and frankly, for graduate degrees, unless you're doing an MBA, what employers really care about is the coursework you took. They care
Yeah,
about,
for sure.
hey, is this interesting? They also care about the projects and the work experience you have. But the nice thing is you already had a ton of related work experience going in. So I love that. I think it makes the most sense to go with the program if they're virtually the same. They cost less money. That's what I did with my grad program. That's one, at least for me, my biggest hang up with a lot of master's degrees is that they are really expensive, especially here in the US, they're really expensive. And, I would never recommend anyone put them in a place of, like financial risk to go back for one of these
Yeah,
programs. There's a lot of cheaper options. Again, if you can afford it and it makes really logical sense like it did for you, there's a very specific reason you want to go back and get a degree, where in a sense you
yeah,
were buying time as well, right? You were buying the,
exactly.
the
Yeah,
focus. But if it's like on a whim, like, oh, I want to get into data science, I should go do a master's degree. I think that decision really requires a lot more
thoughtful.
thought and introspection.
Yeah, it definitely does. And I
So,
think the second point that you wanted me to speak about was around the topics and what it entailed. So, like I said, the course was computer vision, machine learning, and space robotics. Computer vision and deep learning was literally just a quarter of it, of the whole course. Other modules that I took were video and image compression, satellite and remote sensing, signal processing, and space robotics. So space robotics and normal robotics. And I settled on deep learning and computer vision. Those are my strong points. And they were actually the modules that required less maths, because maths is not really my strong point, right? What with deep learning and computer vision, you don't really need to understand the maths. You just have to have an intuition for it, just to know how things operate at a higher level. And you just need to understand the theory, then you can move into the practical aspects of it. You can implement a deep learning model without knowing what a convolution operation is, like what it does, right? So but the other modules were maths heavy, especially robotics, where you had to do a lot of mechanics and you had to do a lot of forward kinematics and inverse kinematics, and it was really challenging and it was good. But the way it's relevant is that with deep learning, it's very relevant with our time, like face detection. There's a lot of gesture recognition, face detection applications out there that you can see on your phone, where you go into the shops, you can just see object detections and surveillance camera being used. So it was very relevant, computer vision and deep learning. And I think that's why I sort of like understood it and grasped it very quickly, because I could literally go from theory to practical.
oh, I find that's, at least for me also, is the best way to learn, is that if I can see an easy way to apply something I'm learning, then it's going to click so much more
Yeah,
because it has real value in my mind in the real world. And so I love that you were able to identify, and that program also seems very highly technical, which I think is a very good thing for anyone looking to pursue a program. My one of my criteria is, okay, are they using tools that are relatively up to date? I think there are a
yeah,
couple programs people are using SPSS, they're using Stata, they're using old technologies for some of the courses that to me doesn't make a lot of sense, right?
doesn't it? Yeah, yeah,
Um,
understand that.
and it again, it appears that your program is pretty close to the cutting edge, especially in that intersection. I mean, computer vision, the technologies, I mean, they change. I mean, in the last 5 years, there's been a lot of movement,
Yeah,
and
for
and
sure.
that's a good thing. So, from your coursework, I'd love to hear how you went about landing your first role, making that pure transition into like the computer vision, the machine learning space. That's something I think your position is, again, fairly unique because you've had really good related experience in software engineering. but what was it like kind of purely making that transition into a new position?
So going from like a web developer to a computer vision engineer, and even trying to get, I'm going to talk about getting the computer vision engineer role out of grad school. So after grad school, I took a break because I was totally defeated after my exams. So I took about like a 3-month break, and I started looking for roles at the end of 2019. December is not really a good time to start job hunting because the offices are gone for holidays. I don't know why I started then. But so January was really when I really started to put more effort. So I would like to think that my previous experience with web development helped, but really people don't seem to care that much within the whole data science and computer vision world, because deep learning world especially. I think it's more because of the roles I was going into and the environment. I was mainly targeting startup environments. So I like to work within startups because they're very fast. You get to learn. It's sort of like a sink or swim environment. So you're forced to learn. I said you're forced to grow. So, and in those environments, you really need people that are able to learn quickly and have previous expertise, and they can show previous expertise. So even though I had like maybe a year or 2 years with web development, people didn't really see that translating into you being able to like handle the actual production of actually object detection model and actually handling object detection within production environment. And rightfully so. There's, as in having a web development career only helped me about 15% if I was to quantify it in my computer vision role, because that's just the programming aspect of it. But with computer vision, there is more than programming. You have to read research papers. You have to stay on top of the field. You have to be updated with the latest development related with the latest state-of-the-art techniques, and you have to understand way more maths than you have to do with web development. And I don't think I ever read a research paper when I was a web developer, but as a computer vision engineer, I'm reading research papers on a daily basis, and I still don't understand them, but I'm just staring. I think through like the process of osmosis, I'll be able to actually acquire some information just by staring at the papers. But that's the massive transition, right? I was in an environment where I was hands-on with code, 9 to 5. But now I'm in an environment where I have to split the practical with the theory, with the reading of research papers. So that's really like one of the high-level difference that I didn't expect making that transition. But again, like I said, like most roles, they're looking for more experienced individuals. But I think that was more for the roles and the environments that I was sort of like putting myself into. I'm sure if like corporate companies or maybe larger companies with a bit more, that will allow you a bit more room to grow, will probably take more entry-level data scientists with maybe no college degree at all and just a few well put together portfolio.
Awesome. Well, I think it's super valuable for, again, anyone watching, where you talked about you still don't understand a lot of the research papers that you read.
Oh yeah.
I think that's a very normal part of data science. Sometimes when I look through a notebook on Kaggle, when I'm reviewing code, when I'm doing some of these things, it still goes over my head. It's, why did they make these decisions? Like, is this a better way to do it? And that's not something to be scared of. That's something to say, okay, well, I clearly need to research more in this area. I clearly need to have a little bit more background in this. And it does kind of work just like you said, maybe not necessarily osmosis, but a lot of the time we don't process things until after we've slept on them. So, you go and your brain does some weird stuff when you sleep, and you wake up and you just understand things incrementally better. It starts to all make sense. And so, for anyone watching, if you're just starting out, you're reviewing these Kaggle notebooks and all the code looks like gobbledygook, I mean, that happens to us too, right? And that's normal, and you have to get used to that. But I mean, eventually, just like what you were talking about before, when it looks scary at the beginning, and then you look back and you're like, oh, it was pretty easy. It's the exact same thing with this process right here. Exactly. So let's talk just a little bit more about computer vision. So do you mind for anyone watching, just defining what computer vision is as a field, and then talking a little bit about what that means in the scope of your current work?
Okay, so computer vision is a field concerned with basically providing systems with the ability to see, just like humans do. That's the most simplest way I can put it. So you have your visual sensory system, and we're able to just sort of like take in all the light, reflection of light, and actually our brain can make sense of it. We're able to identify objects or the texture of objects. So computer vision is concerned with basically taking the intuition or that sort of like functionality and replicating it within computer systems, right? And it as in there's the whole story where computer vision was essentially given to like a student, like a research student back in the either maybe 70s as like a summer task to sort of like solve, to put cameras in a robot eyes to basically allow it to understand what it sees. So they just assumed back then it was going to be like a really quick process, like a little master's course or something, but it turned out to be an entire field. Again, I don't know how true the story is, but you can read it in several different places. But the field itself is grown from like the 70s. It's grown from using sort of handwritten algorithms to detect features, where you basically start with edge detection. So I don't want to get too technical here, but edge detection, one way computer vision works is basically, or one way you can give and make a system understand what it sees is through understanding the structural components that make up an object. And really how you can get the structural components is basically by identifying the edges of the object. So edge detection was one of the early techniques to sort of pull out features from image, and that allows you to then basically create maybe heuristic-based algorithms to basically identify like a box or a shape of a human, right from the edges. And edges are just simply, the way you identify edges is just you look at the difference between you look at the pixel differences, and edges just have high intensity pixel difference, and that's how you detect edges. So back in the 70s, 80s, there were a lot of handwritten, hand-coded, engineered features algorithms. But then with the 80s and 90s, we have the introduction of deep learning. We have the introduction of neural networks. They have the introduction of deep learning. So currently, when we say computer vision, we automatically think deep learning, because deep learning is just an approach to solving solving computer vision. It's the dominant approach, is what works. I don't think they taught us of any sort of there is any other dominant approach that sort of works the way deep learning does. But yeah, deep learning is an approach to solving computer vision tasks.
Sure.
So I could elaborate more on that in terms of what deep learning is, or in terms of what our computer vision task is. So to give an example of a computer vision task is in face detection, object detection, pose estimation, and how all this actually ties into my work as a computer vision engineer is I basically leverage all deep learning modules that are built, and I basically embed them, integrate them within mobile devices. So I use libraries such as TensorFlow Lite, Core ML, and just basically, which provides me with all the tools that I'm needed to basically extract sort of like some sort of scenic understanding from all this deep learning models, and then convert that into some numerical representation that I could then send over to the game developers, and they could then move on to create special effects. So just to put into more practical scenario is, for example, pose estimation. So I leverage a simple pose estimation model and I integrate it into a mobile app. Then I'm able to get the coordinates and of where the joints are located, and I just give that information to the game developers, and they could do pretty cool stuff with it. You could do object tracking with it. You could do face mask and loads of different stuff with it. So really, computer vision is more of it's sort of like an enabling role. My role sort of enables other sort of people within my team to achieve different things. As you just think about anything game related, camera related, or camera games.
Awesome. That's so cool, honestly. What are there any specific computer vision packages that you use? So I know like OpenCV, I think is a pretty popular one. Are there any others that you leverage that are like very use case specific?
Yeah, so yeah, OpenCV is the regular one. I've played around with OpenCV, but I develop for mobile devices. So I use like I said, CoreML. So an iOS, so I use Swift. You use Swift is the programming language that is used to develop an iOS application. So in terms of deep learning packages, I use TensorFlow Lite, which is the TensorFlow, but TensorFlow library, but for the mobile version of it. And they have it in they have the library written in Swift. Also use
I did not
CoreML,
know that.
which is yeah, they do.
Huh.
Yeah, and CoreML is Apple's sort of machine learning library that allows that basically gives you out of the box models, and they have solutions for typical computer vision tasks like semantic segmentation, object detection, gesture recognition. Um, Sometimes I have to come away from the whole mobile side and go back to using GPUs and using Jupyter Notebook when I'm actually going into proper model implementation and training. I have to train on a custom data set. As in there, I use the TensorFlow Python library, and I use other sort of like typical data science packages like NumPy, Pandas, Panda, Pillow, and yeah, all the data science libraries that we typically use. Another popular data machine learning library is PyTorch. PyTorch, TensorFlow are pretty much the popular frameworks and libraries that people use to implement models.
Very cool. Very cool. And so, are you allowed to talk about some of the specifics of one of the projects you're doing at work? Just kind of what that was like. If not, we can go into what some of your personal projects are.
Yeah, I'm not allowed to talk about it in detail. I don't think I can talk about it in any sort of in-depth than I already have, because it's quite
Well,
like a lot of this development and there's some like trade secrets.
no, I completely understand. I'd love to hear about what some of the, I know you are one of the best at working on personal projects. You always have something in the oven. I'd love to hear about what personal projects you're working on. I think that that's something that a lot of people can take some inspiration from. I think that even I could probably learn quite a bit about personal projects from you.
Yeah. So I work on personal projects a lot. It's how I essentially learn, and it's the best way to learn essentially. So one of the key projects I'm working on right now is called Moretion, and it's basically a smartwatch application that basically detects a proximity from your wrist to your face, from your smartwatch wrist to your face, and whenever it gets close to your face, that basically just sends a vibration to alert you that you're about to touch your face or you're touching your face. And the reason why I developed this is because coronavirus is a thing now in 2020. So everyone doesn't want to touch their face. Everyone is basically washing their hands 20 times a day. But I found that I get a bit complacent when I step outside. I forget to not touch my face or not touch my mask. And I just needed something to make me aware or just remind me. So I just spoke to a few friends, and it sounded doable, right? Like you just say the idea, then you just think about it, like how would you like write this in code? And it just sounded there was no reason why this can't be done. So within 2 days, I explored the whole. I created the application on a Apple Watch, just leveraging the sensors on the Apple Watch, gyroscope, the accelerometer, and all that gives you a lot of information and a lot of data that you can just analyze and then just look at the patterns, and you just create a threshold and you can just detect the proximity, right? You can take that a bit further and use machine learning to actually learn the patterns if you use like a recurrent neural network or something. But yeah, so I created that application on an Apple Watch device. Apple rejected it. So
Well,
then I
they're
moved on to
fools.
as in they rejected it for like they would specify the reasons in detail. So I was too lazy to go through it, but essentially just wanted like a research backed proof that it actually works, because I was using the sensors the way they were not intended to be used. So I wouldn't say I was hacking the sensors, but I was just using it the way they didn't want you to use it. So they just wanted more research into does it actually work, and basically they wanted to replicate it and review it before they approved the app. So Apple rejected it, and I just moved over to Android. I looked at like Wear OS. I bought a Wear OS enabled smartwatch, and I looked at the documentation how to sort of work with the sensors on the Wear OS smartwatches, and again, it was pretty easy, right? Just it was a new programming language, Kotlin, but programming languages are quite similar. Once you just work with maybe 2 or 3, you pretty much get the gist. You read the documentations, and within 2 days of just programming, I had the Android version or the Wear OS version of the application. I wrote a Medium article about it.
I'll link
Got
that below as well. So
thanks. So got like some good feedback on it, and now I'm creating a Fitbit version because why not? It seems like the logical step.
I love it, man. I mean, those are the types of things that really get me, excited. I think maybe once you finish, we could co-author a video walking through it. I think that'd be pretty fun.
Yeah,
Something like
for
that.
sure.
We'll shoot a promo. The first commercial, maybe. You never know. So, one thing that I actually legitimately brought us into communication is your belief in how important it is to share your work to kind of create this personal brand. I'd love to get maybe a bit more of your thoughts on the relevance there and why, if you're doing these projects, you should write about them, you should talk about them, you should tell your parents about them, tell your friends about them. What value does that really create?
Really is in sharing your work with the data science community on any platform. So LinkedIn, Twitter, Medium, word of mouth. Just shout out your window.
YouTube.
Yeah, obviously YouTube. It's probably one of the best things you can do for yourself, and quite in terms of career progression. And the earlier you do it, the more benefits you start to reap. So I'm only 8 months into a professional career within the whole machine learning space. But I feel like I've been able to sort of accelerate both my learning and the network I've built in a short amount of time, based on the articles and the content I've put out there to the world. Is in you can do stuff, but you need to let people know you're doing stuff. So I've spoken to people around the globe about computer vision, deep learning projects they're working on. I have meetings on a daily basis, and I don't know why. Some people think I'm an expert, but I know nothing. I literally know nothing in terms of deep learning or computer vision. But the little I know, I guess I know well, and that's because I'm writing constantly technical articles on Medium to reinforce my knowledge. And I feel like that is, again, another benefit, apart from like the self-promotion and exposure, just helping yourself, just learning and reinforcing whatever you've learned, either at school or wherever you've learned at work really briefly, and just writing about it in your own words really just makes the knowledge hit home. And yeah, and you get loads of benefits from it. I can't see a downside to actually sharing the content out there. The world can be brutal, but honestly, I've seen the YouTube comment section, man. But yeah, the world can be brutal. But
all of my subscribers are really nice, so nothing to worry about.
I'm a subscriber, so yeah.
Well, one thing I think it's funny, I just had an interview with my friend Richard, who has the Richard on Data YouTube channel, and he mentioned the Dunningkruger effect. And so that is that, basically the people that believe that they know nothing are the ones that are usually doing the most impressive stuff, because their belief that, that they have so much to learn is actually what pushes them to learn a lot more than someone who perhaps knows even less but thinks they know more. And you're a pure application of that, because although you might not be a so-called expert, you definitely know a heck of a lot more about computer vision than I do. So that's again why I love having these conversations, because honestly, so far I've learned quite a bit, and I love that stuff. I also love learning. Hopefully I've cultivated a pretty good growth mindset as well over the years.
Yeah, for sure. Yeah, I guess so. Yeah, I guess people that don't know nothing typically tend to know a lot. But really, I know nothing. It's in compared to like the greats in deep learning, like Jan LeCun and Jeff Hinton and Andrew Yang. Like I watch their videos like every day, listen to their interviews, and just the way they articulate their sentences is just, and the way they just like put together the ideas and what they've done for the whole deep learning community and just general technology in general is just, it feels like it's almost unreachable, right? But
Almost.
yeah, as in everyone's got
But
to start somewhere.
yeah, well, I mean, that's the thing. I think the beauty is that we're starting our content creation, we're starting our journeys, um, probably around the same time in their lives that they did. And I'm
Yeah,
not
yeah, for
saying
sure.
either of us will reach those pinnacles per se, but I think at the very least, we're making really good strides towards creating value for others and doing some really cool stuff,
Yeah,
which is
for
all you
sure.
can ask for, right?
Yeah, yeah, for sure. As in, I just recently wrote two articles. One is on like introduction to computer vision, and the other is like a introduction to deep learning. So I can give you like a link and you can share with your
Heck yeah.
subscribers for those who are actually quite interested in actually knowing what the field is about and what it entails. Yeah, yeah, for sure. And
Heck yeah.
yeah,
Awesome. So those are all the questions I really had for you. At the end of the interviews, I leave the floor open for you to talk about, again, any more projects you're working on, any initiatives you're talking about, any causes you care about, or any just parting words of advice that you might have. So the floor is
um,
open to you.
an open floor to say anything I want. Wow. Um, Really, it's just pretty much what's worked for me, and it's just having that growth mindset. Don't like, I never try to get too comfortable wherever I am, and I'm constantly pushing myself. And you might look at like, I guess that's why you see like I worked in 4 different roles in within like a year and a half, because essentially when you get comfortable, you start to learn, you start to get complacent, and you fall behind the times, and you just have to keep pushing. And even though it seems hard and it seems impossible, eventually one day, 10 years, is going to look back and it's all going to be easy, right? And another parting word is to like and subscribe. Is in like and subscribe to Kenji's channel, man.
That was
Yeah,
unprompted,
definitely.
just to be clear. No, yeah, I love that. I think that a growth mindset is kind of synonymous with data science. I mean,
Yeah,
or
for sure.
machine learning or computer vision. These things change relatively rapidly, and
They
we have to
do.
believe we can change with them, or else we're going to get kind of left behind here.
As in, yeah. As in, there's a whole philosophical aspect to whole intelligence and that we can probably discuss in a future video or something. Yeah, but computer vision, deep learning, machine learning is really where it's at. So it's really the forefront. So try to get on board any way you can.
I love it. Thank you again for coming in and chatting with me, Richmond. This was awesome.
Thanks a lot. It's a pleasure.